Welcome everyone. In this video, we will discuss exercise 4.1 from the book Introduction to Real Analysis by Bartle and Sherbert. So let us start with the first question of this exercise. So in the first question, we are asked to determine a condition on x minus 1 that will assure that x square minus 1 is less than 1 by 2 or x square minus 1 is less than 1 upon 10 raised to the power minus 3. Then in the C part, we are given that x square minus 1 should be less than 1 by n. And in the fourth part, we are given that x cube minus 1 should be less than 1 by n. So we have to find some condition on x minus 1 such that these holds. So for that, what we will do, we will express. So let us start with B part of this. So question 1, B part I will discuss. So it is, we have to show x square minus 1 is less than 1 upon 10 raised to the power minus 3 and for that using some condition on x minus 1. So basically this is nothing but, so here epsilon is equal to 1 raised to the power 10 minus 3 and we have to find some delta greater than 0 such that x minus 1 less than delta should imply x square minus 1 less than epsilon. So this is what we have to find. So consider x square minus 1. So we can write using the formula a square minus b square equal to a minus b, a plus b. I can express x square minus 1 in terms of this. So now using triangle inequality, I can write it like this: mod x plus 1. So this is using triangle inequality. Fine. So now if I can find some number greater than this, then I will be able to solve. So for that I will take some bound on mod x minus 1. So let mod x minus 1 to be less than 1. So since this is in numerator, so we can take any positive real number at this place. Since x is only in the numerator, so we can take any positive real number in place of 1. So since 1 looks good, so I am taking 1. You can take any positive real number in the place of 1. So then if I will use the reverse triangle inequality, so using reverse triangle inequality, what I have mod x minus mod 1 is less than equal to mod x minus 1. So this implies mod x minus 1 is less than 1. Since mod x minus 1 is less than 1, so then it implies mod x is less than 2. Now I can use, so this is our star. So using this in star, we have, so now when we use that in star, so what we will get, mod x square minus 1 is less than 3 times mod x minus 1. Fine. Whenever mod x minus 1 is less than 1. This is the condition that we took, so we have to write this condition. Under this condition, this holds. So now I want this to be, so now I want this to be less than epsilon. So for that I have to take some condition on this. So I will take delta equal to minimum of we generally, when we express fx minus L to be less than equal to k times some x minus c, k times x minus c. So this, whenever we express like this, then we take delta equal to epsilon by k. So what delta we should take? We should take delta equal to epsilon. So epsilon was 1 epsilon by 3 and 1. So this is equal to minimum of 1 by 10 minus 3 into 1 by 3 and 1, and this is equal to minimum of 10 raised to the power 3 by 3 1, and this is nothing but 1. So we get delta to be, if I take delta to be less than 1, then this condition holds for me. So this condition holds for me. Now let us take another, let us go take next question. So you can do these questions on the similar line, so I am not doing other parts of this. I am going to question number 2. It is similar to first part, but let us solve this, because in this we will have x in the denominator. So let me choose this question. So first I took, let me mark also what questions I have done. So I have done this question. Now I should do, let us do this question. Fine. So I'm again taking the second part of this. So I want to add a new page. So this adds the new page. So in this page, what we should do, I will solve question number 2 B part. And what is the question? I have to determine a condition on x minus 4 so that root x minus 2 is less than 10 to the power. So find condition on x minus 4 so that root x minus 2 is less than 10 raised to the power minus 2. So in this case, let epsilon, so here, so here epsilon is equal to 10 raised to the power minus 2, and we have to find delta greater than 0 such that mod x minus 4 less than delta should imply root x minus 2 less than epsilon. So this is what we want. We want to find some delta greater than 0 such that root x minus 2 is less than epsilon. So let us start. So consider, so let me consider root x minus 2. So I will try to express this in terms of x minus 4. So for that, what I will do, I will multiply and divide by this, and so this will be equal to x minus 4 root this is equal to x minus 2 root x plus 2. And now, so since we have, this is in terms of this, I want to replace this by some constant k such that I get this type of thing. So I want to express this in terms of this k times x minus 2. So I have to take some bound on x minus 4. So let us take some bound on x mod x minus 4, and since our x is in denominator, so the bound should be at least half of this. Since this is positive, so we don't have to equate denominator to 0 to get the bound. We just have to take the bound to be half of 4. So in this case it is 2. So when we take this bound, now open this bound, so it will be, this implies minus x minus 4 lies between minus 2 and 2, and when adding 4 to all the sides we get 2 is less than x is less than 6. So we use this in star. This is our star. So using x greater than 2 in star, we get root x minus 2 is less than 1 by 2 plus root 2 mod x minus 4. So what delta we should take? We want this to be less than epsilon, so delta should be equal to 2 plus minimum of 2 plus root 2 epsilon, and next condition is 2. So epsilon here was equal to 10 raised to the power minus 2. So this is equal to minimum of 2 plus root 2 into 10 raised to the power minus 2 and 2. So this is 3.41 into upon 100. So minimum is obviously this. So minimum in this case is equal to 2 plus root 2 into 10 raised to the power minus 2. So this is the delta we want. So for this choice of delta, x minus 4 less than delta implies root x minus 2 is less than epsilon, which is 10 raised to the power minus 2. So this is the second question. Now let us try some other questions. So I have done one part from question number 1, one part from question number 2, and let us see what the question number 3 says. It says we have to show that limit x tends to c, fx is equal to L if and only if limit x tends to c mod fx minus L is equal to 0. So question number 3, to show limit x tends to c fx is equal to L if and only if limit x tends to c mod fx minus L is less than is equal to 0. So this we have to show. So let us start with the proof. So limit x tends to c fx equal to L. So this is equivalent to saying that for each epsilon greater than 0 there exists delta greater than 0 such that 0 less than x minus c less than delta implies fx minus L is less than epsilon, and this is equivalent to writing for each epsilon greater than 0 there exists delta greater than 0 such that 0 less than x minus c less than delta implies. Now I want to express this in terms of this. So what I will do, I can write the above like this: minus 0 is less than epsilon. So this is now my function. This is function minus 0 less than epsilon. So this is equal to this. So I can rewrite this in the form of this. So now by definition of this, it follows that limit x tends to c mod fx minus L is equal to 0. So this is the proof of question number 3. Now let's move to the question number 4. So what it says, we have to show that limit x tends to c fx is equal to L if and only if limit x tends to 0 fx plus c is equal to L. So this time we have to make some changes in our delta. So let us, question number 4, to show limit x tends to c fx equal to L if and only if limit x tends to 0 fx plus c is equal to L. So this is what we have to show. So what we will do, we will start with the proof. So let us start the proof. So we have to start. So let limit x tends to c fx equal to L. So this is equivalent to, by definition of limit, for each epsilon greater than 0 there exists delta greater than 0 such that what we can write, 0 less than mod x minus c less than delta implies mod fx minus L is less than epsilon. So this is what the definition of limit says. Now we want to express it in terms of fx plus c. So how we will do that? So this is equivalent to writing, for each epsilon greater than 0 there exists delta greater than 0 such that I can write it like this: 0 is less than x minus c minus 0 less than delta implies fx. So I can write it like this: fx minus c plus c minus L less than epsilon. So we can write it like this: fx x minus c plus c. So this is minus L less than epsilon, and this is equivalent to writing, for each epsilon greater than 0 there exists delta greater than 0 such that 0 is less than y minus 0 less than delta implies f y plus c minus L is less than epsilon. So what we are doing, replacing x minus c by y. So this is what we have done. So we have replaced x minus c by y. So now by definition of limit, what we get, this is equivalent to saying that limit x tends to 0, because y minus 0 is less than delta, implies f of y plus c is equal to L. So this proves question number 4. Now let us move to the next question, which is question number 5. So what is there in question number 5? We have been given an open interval I, which is 0 to a, where a is some positive real number, and we have defined a function g equal to x square on I. Then for any points xc belonging to I, we have to show that gx minus c square is less than equal to 2a times mod x minus c, and then using this inequality we will have to show that limit x tends to c, x square is equal to c square. So let us get back to this question. So question number 5, I is given to be 0 to a is positive, g is defined from I to r as gx is equal to x square for all x belonging to I, to show gx minus c square is less than 2a times x minus c. C belongs to I is any point, so I have to show that gx minus c square is less than this. And so to prove this, let us consider gx minus c square. So this is equal to x square minus c for all x belonging to I, and this I can write as x minus c, x plus c, and this is less than equal to x minus c mod x plus mod c using triangle inequality, and this is less than x minus c a plus a. Since xc belongs to I implies mod x is less than equal to a and mod c is also less than equal to a. So both are less than equal to a, so we are replacing mod x by a and we are replacing mod c by also a. So this is equal to 2a times mod x minus c. Next we have to show that limit x tends to c, x square is equal to c square. This mark it as star. Now also consider x square minus, so we have to find by definition for each epsilon greater than 0. So let me first choose an epsilon, arbitrary epsilon. So let epsilon greater than 0 be any real number. So I have to find some delta greater than 0 such that to show there exists delta greater than 0 such that 0 less than x minus c less than delta should imply x square minus c square less than epsilon. So consider take delta equal to epsilon by 2a. We are choosing this type of epsilon because of this star condition. From star we have x square minus c square less than equal to 2a times mod x minus c. So I want this to be less than epsilon, so I will take delta equal to epsilon by 2a. So then 0 less than x minus c less than delta implies x minus c is less than epsilon by 2a, and this implies 2a times x minus c is less than epsilon. So from star it follows that, so from star we have 0 less than x minus c less than delta implies x square minus c square is less than epsilon, hence limit x tends to c, x square is equal to c square. So this is the proof of question number 5. Now let us move to question number 6. So question number 6, okay, so we have to show there exists constant k and l such that fx minus l is less than equal to k times, okay, this is given, and we have to show that limit x tends to c fx equal to l. Question number 6 given is there exists constants k and l such that mod fx minus l is less than k times x minus c. To show limit x tends to c fx is equal to l. So what we will do, we will let epsilon greater than 0 be any real number, choose delta equal to epsilon by k, then 0 less than x minus c less than delta implies x minus c is less than epsilon by k, and then this will imply that k times x minus c is less than epsilon. Now by a given condition, now since fx minus l is less than k times x minus c, so it follows that fx minus l is less than epsilon whenever 0 is less than x minus c less than delta. So this is our star, so using star this we are getting using star. So then by definition of this is the definition of limit, so this implies limit x tends to c fx is equal to l. So this is the proof of question number 6. So now let us move to the question number 7. So we have done, let us mark what all we have done. So we have done question number B, this, then we have done 3, 4, 5 we have done 6. Now I will do question number 7. I have already done in my video. 7 is already there in the video, so I am not doing question number 7 here. You can watch in my video. Now let us take question number 8. Question number 8, to show limit x tends to c root x is equal to root c, where c is given to be greater than 0. So let epsilon greater than 0 be any real number. So then by definition of limit, what we have to show? We have to show there exists delta greater than 0 such that 0 less than mod x minus c less than delta implies mod fx. Sorry, mod fx here is root x. So we have to show this root x minus root c is less than epsilon. So we have to find our delta in such a way that this should imply that root x minus root c is less than epsilon. So for this we will express root x minus root c in the form of k times x minus c, and then we will take delta equal to epsilon by k. So consider root x minus root c. So this is equal to, what I will do, I will multiply and divide by root x plus root c. So I am multiplying and dividing by root x plus root c, and again this is equal to, so now if I will rewrite, so this is 1 by root x plus root c. This both are positive square roots. I can remove the mod, and this is x minus c. So I have to replace this by some k. So I have to find, so I will have to take some bound on x minus c, and since our x is in denominator, so I have to take, let x minus c to be less than c by 2. Because our x is in denominator, so we cannot take any positive real number at this place. We have to take something smaller than c, so I am taking c by 2. Then this implies minus c by 2 is less than x minus c is less than c by 2. Then adding c to all the sides, we get c by 2 is less than x is less than 3c by 2. So I will use this inequality. So using x greater than c by 2 in star, we get, so what we get, yes, root x minus root c is less than 1 by root c by 2 plus root c times x minus c. Whenever, this is true whenever x minus c is less than c by 2. Now let k equal to 1 by root c by 2 plus root c, and delta equal to epsilon by k. Then by the choice of delta, we have 0 less than x minus c less than delta implies root x minus root c is less delta equal to, so we have to take delta equal to, this delta will not work, we have to take delta equal to minimum of epsilon by k and c by 2, because this is the extra condition that we have put, so we have to include this at this place. So then this is less than epsilon, hence limit x tends to c root x is equal to root c. So let us try some more questions. So what we will do, we will take one more question. Now question number, so we have done question number 8 also. Now question number 9. So we have to use either epsilon delta definition of limit or sequential criteria for limits to establish the following limits. So we will do, let me solve for you this question number C and question number D because they are more tricky. So we will do question number C and question number D. So first let us start with question number C. Question number 9, C part, to show limit x tends to 0, x square by mod x is equal to 0. So what we will do? We will take, let fx is equal to x square by mod x for all x belonging to r minus 0, because this is not defined at 0, so we will exclude the 0, and since 0 is an since 0 is a cluster point of this, so we can still define limit at 0. So let fx equal to x square by, so this will be equal to x square by minus x if x is less than 0, and x square by x if x is greater than 0. So this is nothing but, so this is equal to minus x if x is less than 0 and x if x is greater than 0. So this is nothing but mod x. So consider, so let epsilon greater than 0 be any real number. So we have to find, to show there exists delta greater than 0 such that 0 less than x minus 0 less than delta should imply fx minus 0 less than epsilon. So this is what we have to show. So consider mod fx minus 0, which is nothing but mod of x minus 0, and this is nothing but mod of x, and this can be written as mod x minus 0. So taking delta equal to epsilon, now we get 0 less than x minus 0 less than delta implies fx minus 0 is less than epsilon. So hence limit x tends to 0, fx is equal to 0 by definition of limit. So this is the C part of question number 9. Let me do D part. Question number 9, D. And what was the D part? We have to show limit x tends to 1, x square minus x plus 1 upon x plus 1 is equal to 1 by x square minus 1. So question number 9, D part was limit x tends to 1, x square minus x plus 1 upon x plus 1 equal to 1 by 2. This we have to show. So let us take the solution. So we will choose any epsilon greater than 0. So let epsilon greater than 0 be any real number to show there exists delta greater than 0 such that 0 less than x minus 1 less than delta should imply x square minus x plus 1 upon x plus 1 minus 1 by 2 should be less than epsilon. Now, so for this we have to express this in terms of mod x minus 1. So consider x square minus x plus 1 upon x plus 1 minus 1 by 2. So this is equal to 2x square minus 2x plus 2 minus x minus 1 upon 2x plus 1. So this is reduced to what we are getting, 2x square minus 3x plus 1. So x plus 1 times 2, so this is nothing but, if I will simplify it, so minus x plus 1. So I am splitting the middle term, and this is, if I will write, this is nothing but, this is nothing but 2x minus 1 and x minus 1 upon 2x plus 1. So this we are getting, what we are getting? We are getting 2x minus 1 upon 2x plus 1 x minus 1. So right. So we have to reduce the numerator to, using triangle inequality, I can write it like this: 2 times mod x plus 1 upon 2 mod x plus 1. Denominator we will not use triangle inequality because we have to reduce the denominator by something smaller. So using triangle inequality. Now since denominator is 0, now x plus 1 equal to 0 implies x is equal to minus 1, and this implies mod x is equal to 1. So anything smaller than this will work as a bound for mod x minus 1. So I will take, let mod x minus 1 to be equal to 1 by less than 1 by 2. So I am taking mod x minus 1 to be less than 1 by 2. So this implies minus 1 by 2 lies between x minus 1 to 1 by 2, and this implies 1 by 2 lies between 3 by 2. So we will use x greater than 1 by 2 in denominator and x less than 3 by 2 in numerator. So this I will use in denominator, and this I will use in numerator. So using, so this is our star. So in this I will use, so using x greater than 1 by 2 in denominator and x less than 3 by 2 in numerator, we get, so what we are getting? We are getting that x square minus x plus 1 upon x plus 1 minus 1 by 2 is less than, I am replacing mod x by 3 by 2 plus 1, and denominator I am replacing by 1 by 2, and here I have x minus 1. So this is equal to 4, 2, so 4 by 3 mod x minus 1. So take delta equal to minimum of epsilon by k, so for 3 epsilon by 4 and half. Then for this choice of epsilon, for this choice of delta, 0 less than x minus 1 less than delta implies x square minus x plus 1 minus 1 by 2 is less than epsilon. Hence limit x tends to 1, x square minus x plus 1 upon x plus 1 is equal to 1 by 2. So we have done question number 9. Now in the next video I will solve question number 10 to question number 17. So I will solve these questions in part 2 of this video. 10 to 17 I will show in the next video. Thank you.